Exercise 4.3 question number 6. We did earlier till question number 5, and I just explained you that how in integration by parts you follow some rules. The first one was that you can also consult in the previous video that is explained properly explained in the first part of this exercise. These are the three rules you will follow in integration by parts method. If you have any function that have no integration formula, you will just name it as first function. If both of them have integration formula, then you will just take their derivative. If any of the function is reduced by taking the derivative, you will just name it as first function, and the remaining one will as second function. If in any question both of them have integration formula and we cannot, after taking the derivative, we cannot specify which of them is reduced, then we can name them any of the number, first or second or first, and we will just let that integral equals to some capital alphabet. That three rules and the formula of integration by parts is clearly explained in this exercise part 1. You can consult to that video. So just start from question number 6. Integration of cosecant cube of x. This is the same as question number 5, that is in exercise 4.3 part 1 video. Just split it into two functions, cosecant square of x and cosecant of x. Now if we take the integration of cosecant square of x, it has also a formula. Integration of cosecant x also has integration formula. So first rule is not applicable here. Go towards the second rule. Just take the derivative separately. After taking the derivative of cosecant square of x and cosecant of x, we cannot specify which of the function is reduced by differentiating. So we cannot use the second function as well. Now move on to the third function. Third rule. In the third rule, you can give them any of the number. Like I have given this one as first function and this one as second. You can also name them, this one as first and this one as second. But quickly let this integral equals to some capital alphabet. Now, in using the integration formula, first function will come as it is. This first function will come as it is into integration of second function. Second function is cosecant square of x, and integration of cosecant square of x is minus cot of x. This is minus sign is in the formula of integration by parts. So this is the formula minus main integral, then derivative of first function. Derivative of first function is minus cosecant of x cot of x into integration of second function. This is the same integration. So you can also just directly write it here, dx. This left hand side is written as it is. Now come towards this integral. This minus will become plus cosecant x cot square of x. We know that 1 plus cot square of x is equals to cosecant square of x. So we can separate the cot square of x out of it and we'll get cosecant square of x minus 1. Multiply this cosecant of x inside this bracket and split this integral. Minus will become plus here. Now you see we got again the same question as cosecant cube of x. What we let it equals to? We let it equals to capital I. So just write in place of this integral as capital I. Integration of cosecant x, this is the direct formula that is used here. You also know that this was given in the start of this chapter, the table of integrals. Now minus I will go on the left side. This will become I plus I, that is 2I, and now 2 will go here in the division. So we got this minus 1 by 2 cosecant x cot x plus ln cosecant x plus cot of x plus c. Question number 7. Integration of x minus sine of x dx divided by 1 minus cos of x. This can be easily simplified as x can be written as, we know that 2 into x by 2. So I have just replaced x with 2 into x by 2. Now we know that sine 2 theta is equals to 2 sine of theta cos of theta. So here theta is x by 2. It will be written as 2 sine x by 2 and cos of x by 2. Now same thing will happen in the denominator. Cos 2 theta has the formula cos square of theta minus sine square of theta. So just replace this whole value here and multiply this minus sign with this whole term. Will get 1 minus cos square x by 2 plus sine square x by 2. Now we know that cos square of theta plus sine square of theta is equals to 1. we can just replace this 1 minus cos square of x by 2 by using this identity as sine square of x by 2. Sine square of x by 2 plus sine square of x by 2, we will get 2 sine square of x by 2. Now we have one function in the denominator that can be separately written with this function and this one as well in the separate integrals. Like this. This is 1 by 2, this can be separated like this, and 1 over sine square x by 2 can be written as cosecant square x by 2 dx. Then this 2 will be cancelled with this 2. Sine x by 2 will be cancelled with this 1 of the sine x by 2. We will get cos x by 2 over sine x by 2. That is equals to cot of x by 2 dx. Now we can just use here the integration by parts formula. We know that both of them has the integration formula. So just move on to the second rule. Just check their derivatives. If I take the derivative of x, it will be reduced to 1. So we will specify it as first function and this one as second function. Do not do anything with this integral, because we know that if we take the derivative of cosecant square of x by 2, we will get the same function as cot of x by 2. So maybe the functions will be cancelled with each other. So do not just take the derivative of this. Just keep it as it is. Now first function will come as it is, into integration of second function is minus cot of x by 2 over 1 by 2 minus integral derivative of first function into integration of second function. The last thing will come as it is. Open this whole bracket, simplify the terms. This 1 by 2, when will moved upward because it is in the fraction form, it will become 2 minus 2x cot x by 2. Now this, the same thing will happen here. This will become minus minus plus 2 integral cot of x by 2. Open this whole bracket, multiply 1 by 2 inside. We see that we got the same integral. So the answer left behind is minus x cot of x by 2 plus c. Now come to question number 8. Integration of x sine inverse of x dx. Now starting from the first rule, x has the integration formula, but sine inverse of x has no integration formula. So it will be taken as first function because it has no integration formula. First function into integration of second function minus integral sine derivative of first function. Derivative of sine inverse of x is 1 over under root 1 minus x square into integration of second function dx. Now I can make this same function here upside because I have x square here. I need minus sign with this x square. So just I will take this minus sign inside and keep it here plus sign like this. Now I need 1 here. So for that purpose I will subtract and add 1 here. Now these are two functions. We can separate it like minus 1 over this and 1 minus x square over this. We know that integration of minus 1 over integration of this one minus will come outside like this, and integration of 1 over 1 minus x square under root is sine inverse of x. And this is the same thing, 1 minus x square. This is 1 minus x square. That can be written as 1 minus x square into 1 minus x square. 1 under root will be cancelled with this. We will be left by integration of 1 minus x square. That also has the direct integration formula, half of sine inverse of x plus x by 2 under root 1 minus x square. Just open this bracket. After opening this bracket, we see that both are the same with different coefficients. 1 by 4 minus 1 by 2 will give us minus 1 by 4 sine inverse of x, and the rest of things will come as it is. Question number 9. Integration of x cube under root x square plus 1 dx. X cube can be written as x square into x. Now I just made here 2 because I know that x square has the derivative 2x. That will be maybe needed somewhere after using the formula of integration by parts. So I just made 2 here by dividing 2 and by multiplying 2. Now we see that this also has the integration formula, this whole thing, because it has the derivative with itself. This is the integration formula, the first rule is not applicable. Go to the second rule. Check any function which is reduced after taking the derivative. x square will be reduced to 2x after taking the derivative. So this is the first function and the remaining thing will be second function. Now using the integration by parts formula, apply the main brackets because we have some constant term coefficient here. First function x square will come as it is into integration of second function. The main function is x square plus 1, this power 1 by 2. Now this can be easily integrated by adding in power 1 divided by that power if it has derivative with itself. Now you see x square plus 1 has a derivative 2x, that is with it. That's why we will just add in the power, that is 1 by 2 plus 1, and the same thing will divide here. After 1 by 2 plus 1 we'll get 3 by 2 and 3 by 2 here. Minus integral derivative of first function into the same answer, integration of second function dx. Now this 3 by 2 will become 2 by 3 and the remaining things will come as it is. Now I just move this whole 2 by 3 outside like this and remain this 2x inside, because this 2x is again the derivative of this inner function. Now we can easily integrate it because it has the derivative with itself, power plus 1 divided by that power. Simplify the terms, 3 by 2 plus 1 will give us 2 by 5, 2 by 5, and 3 by 2 plus 1 give us 5 by 2, and here we will also get 5 by 2. It will be moved up to give 2 by 5. Just simplify the terms, open this bracket, and we will get this answer. Now question number 10. Integration of e raised to power x into 1 plus x ln of x over x dx. This, we have two functions here in the numerator. It can be separated as 1 over x plus x ln x over x, that will give us this answer. Now separate both of the integrals. Integral e raised to power x 1 over x as this, plus integral e raised to power x ln of x like this. I'm not just solving this, I'm just solving this one, because we know that if I take the derivative integration of 1 over x, I will get ln x. So same thing will come again and we can cancel the integrals. First function and second function. Now first function will come as it is, into integration of second function is ln x minus integral derivative of first function into integration of second function dx. Last thing will come as it is. Now you see both of them are same, they will be cancelled because they have the negative sign, opposite sign. So the question number 10 answer is e raised to power ln x plus c.